packaging integrity, it's all about understanding what the container needs to do to maintain those barrier properties to assure quality, right? It's very different for a variety of products. And to put it in perspective, that circle in the center of the screen, that is the diameter of a human hair, right? And when we begin to look at micron-sized defects or single-digit micron-sized defects, we're concerned with bacterial ingress, moisture ingress, oxygen ingress. All of those things will happen in that single-digit micron range. And so what you can see is that big circle in the center is a human hair that's about 80 or 90 microns. And we are still concerned with defects down in that 1 to 10 micron range. That single-digit micron range can still serve a very critical risk to the product. Another thing that you have to consider is that you can have multiple 1 micron defects, and they can collectively cause an impact to the product itself. And that's something to pay close attention to. So just because we don't have a single defect of 1 micron, there may be a flow into or out of the container that causes the degradation that's critical to this product, right? So oxygen and moisture can collectively flow through multiple defects. Bacteria, which if we look at that chart on the right, bacteria is focused, it really, a bacteria has to propagate through a single defect of a certain size to get into the container and affect the sterility of that product. So this chart on the right shows, and it's from the Lee Kirsch study, 1997 study, and I apologize that it's not referenced here, but Lee Kirsch presented this data, and it showed that defects in that single-digit micron range still present a significant risk to product. They present that risk of sterility, failure, right? Not all defects are physical, and not all visual defects, or not all physical defects are visually manifested. So just because you can't see it, it may still be there.